In this lesson, we're going to be understanding differences between linear and nonlinear functions. The success criteria is I can recognize linear functions represented as tables, equations, and graphs, and I can compare linear and nonlinear functions. The graph of a linear function shows a constant rate of change. A nonlinear function does not have a constant rate of change, so its graph is not a line. For this example, we're going to see if each table represents a linear or nonlinear function. Well, if you remember, a linear function has a constant rate of change. So if our change in y relative to change in x is constant, then we know it's going to be a linear function. If it is not, then we know it's not going to be a linear function. So let's look at the first table and see what's happening. So I'm going to start with y. So each time here, I see that I'm subtracting 8 to get to the next y value. So I'm just going to write that down. Minus 8, and then minus 8, and then minus 8. All right, and as that's happening, let's look at our x values. Well, each x value is going to be increased by 3, right? 3 to 6, that's plus 3, plus 3, plus 3. So every time that I increase x by 3, I'm decreasing y by 8. And because this is a constant rate of change, we know that this is a linear function. And our explanation that they're asking for is because of the constant rate of change. So now we're done with this table. Let's move over to the other table. So let's see what I'm doing in the x. And it doesn't matter which one you start with, x or y. Here, x, I see that I'm increasing my x by 2 each time. Plus 2, and plus 2. All right, and as I'm increasing my x by 2, let's look at our y's. So from here to here, I'm adding 9. You could have done 11 minus 2 to figure that out. But that's going to be plus 9. But then from here to here, I'm doing plus 22 because 11 plus 22 is 33. So we can already see that this is not going to be a constant rate of change. And then just to finish this off, this is going to be plus 55. So as I'm increasing x by the same amount, I'm increasing y by different amounts each time. So this is going to be nonlinear because no constant rate of change. CROC, constant rate of change. Anyway, we've successfully identified our functions as linear or nonlinear, and now we're done with this one. In this example, we need to figure out if each equation represents a linear or nonlinear function. And then we need an explanation. Well, if you remember, all linear functions can be written in the form of y equals mx plus b, where m is the slope, b is the y-intercept, and then x and y is your xy pair of any point on that line. So what we're going to try to do is rewrite our functions up here in slope-intercept form, and if we can, then it will be linear, and if we can't, then it will be nonlinear. So let's start with part A. This is going to be y equals 4 times the quantity x minus 1. And all I need to do is just distribute this. So I get y equals 4x minus, well, negative 1 times 4 is negative 4. So I get 4x minus 4. And if you see, this is in slope-intercept form. I can easily identify my slope as 4 and my y-intercept as negative 4. So because of that, this is a linear function. And the explanation would be because it's in slope-intercept form. All right, for part B, I see y equals 4 over x. I'm going to rewrite that. And if you see in our slope-intercept form, which is what we're trying to base this off of, there's no x on the bottom of a fraction, okay? We can never have x on the bottom of a fraction. We can have a fraction next to our x, but not having the x on the bottom of the fraction. So right away, I can recognize that this is going to be a nonlinear function right here. So I'm going to write nonlinear because it cannot be written in slope-intercept form. And now we're done with this one. For this example, we need to represent if each graph represents a linear or nonlinear function. So it's actually pretty easy to tell when you're looking at a graph. The word linear here, I'm going to zoom in, has the word line in it. So if your function is a line, then it will be a linear function. If it is not a line, then it will be a nonlinear function. So I'm going to go back here. Clearly, this is not a line. This is a curve. Okay, so this is not going to be a linear function. Therefore, it is a nonlinear function. So nonlinear. And then over here, this is clearly a line. This function is a line, right? It's a horizontal line, but a line nonetheless. So this is a linear function. And now we're done with this example. For this example, two accounts earn different types of interest. The table shows the balances of each account for 5 years. Graph the data and compare the balances of the accounts over time. So all we're going to do here is plot our ordered pairs. Okay, the ordered pairs are going to be 0, 1, 2, 3, 4, 5. That's going to be our input value, and then our outputs for account A will be here, and then our outputs for account B will be here. So I'm going to do account A in blue, and then account B in pink, so it's easier to tell on the graph. So I'm just going to plot these ordered pairs for account A. So first I'll do 0, 100. And by the way, this little squiggly thing, if you didn't know, this basically just shifts up the x-axis. Okay, so this is not to scale from 0 to 100, but then the rest are counting by tens on this scale. Anyway, so I'll plot 0, 100. Okay, so that's going to be right here. And then 1, 110. And then 2, 120. 3, 130. 4, 140, 5, 150. So if you see, this is a linear function, right? Because I could draw a line through these points. I can go up 1 space, right 1 space, or up 10 units, right 1 unit, and this is going to be a constant rate of change. So I know that this is a linear function. Now let's do account B. So I have the point 0, 100 again. And then I have 1, 110. My first two values are actually the same. Then I have 2 and 121, so $1 more. Somewhere like that. And then I have 3, 133.1. We're going to graph this the best we can. Something like this. Then I have 4, 146.41. So it'll be like that. And then I have 5, 161.05. So that'll be somewhere like there. All right. So it's kind of hard to tell, but you can see that it's not going to be a linear function because we do not have a constant rate of change. Okay. From here to here, from this point to this point, I'm going up 10, right 1. But then from here to here, I'm going up 11, right 1. Okay, and then right away you can tell it's not going to be linear. Account B is actually an example of compounding interest, which is an example of exponential growth, and you'll learn that in a later course. But for now, all we need to know is that account B is a nonlinear function and account A is a linear function. And now we're done with this example.